Hello, everyone. Welcome to our lab today. This is the determination of the Ksp of a slightly soluble compound. The determination of the Ksp of a slightly soluble compound lab. Okay. Before we start the lab, I want to quickly remind you about safety. You need to have your goggle on, your lab coat, and a shoes that completely cover your toe before you come to lab. And when you are in the lab too, make sure you have those on all the time. Okay. And now coming back to the lab, the purpose of this lab is to actually uh, calculate the Ksp, okay, and the molar solubility of calcium hydroxide. Okay, calcium hydroxide will uh, dissolve slightly, okay, into a solvent, okay, any solvent. So the purpose of this lab is to actually determine the molar solubility and the Ksp of calcium hydroxide. So this can be done by titration. It can be done by titration. Okay, so before we move to the titration parts of the lab, you need um, a stand, a clamp that will hold the burette. Okay, need three 250 milliliter beaker, need a phenolphthalein. Okay, need a phenolphthalein. You need a saturated solution of calcium hydroxide. Okay, have you here saturated solution of calcium hydroxide, and you also need a 0.05 molar hydrochloric acid. Okay, other than that, you also need 100 milliliter graduated cylinder. Okay, so for the procedure of the lab, the procedure has two parts. Okay, in part one of the procedure, you have to prepare the burette. You have to prepare the burette, okay, for the titration. Okay, how you prepare the burette? You need to, you're gonna fill up the burette with hydrochloric acid. So you need to clean the burette first. Okay, clean it. So you have to fill the burette up to 0 with HCl, hydrochloric acid, and drain it out, drain the solution out. This is how you clean gas. So I have done it before we start the video. Okay, now I fill it back with hydrochloric acid to 0. Okay, this is what I'm gonna use actually to titrate the calcium hydroxide. Okay, so that's the part for the preparation of the burette. Okay, now part two is the titration. Okay, you're gonna proceed to the titration in part two, but before you proceed to the titration in part two, you need to fill the 3 beaker. Okay, fill the 3 beaker with 20 milliliter of calcium hydroxide, okay, calcium hydroxide. Need to fill the 250 milliliter with calcium hydroxide. Okay, after you fill it with, you fill them with 20 milliliter of calcium hydroxide, you need to add 5 drop of phenolphthalein. Okay, 5 drop of phenolphthalein to each one. Now, what is the role of phenolphthalein in this titration? Phenolphthalein is a color indicator. Okay, so it will tell you that you get to equivalence when you are doing the titration. Okay, now I have one of the beaker. If you can see, the color of the solution is pink. Okay, in one of the beaker, because I already add the 5 drop of phenolphthalein to that already. Okay, to that solution. Now I'm gonna do the same for the second beaker and the third beaker. Okay. Now for the second, you can see that the solution is clear. Okay, and then as soon as I add the drop of phenolphthalein, it become pink. Okay, you know, phenolphthalein will become pink in a base. CaOH2 is a base. Okay, that's why we are getting the pink color. Okay, put more here. Okay, okay. Now uh, you have we have our burette filled with HCl, hydrochloric acid, 50 milliliter of hydrochloric acid, and we also have 3 beaker, okay, filled with 20 milliliter each. 20 filled with 20 milliliter of calcium hydroxide, okay, and we also make sure we have the 5 drop of phenolphthalein. Make sure you have your 5 drop of phenolphthalein in each one. Okay. Now we're gonna proceed to the titration. Okay. So you're gonna titrate each solution with HCl. So you get your beaker, okay, to the burette, okay, and you have to start dropping the HCl by increment of 1 milliliter. Anytime you drop 1 milliliter, chill the solution in the beaker. Okay, you chill the solution to make sure it mix. Okay, you get a good mix. This is how you're gonna know also quickly that you get to the equivalence point, because at the equivalence point, what will happen is that the pink color will change to clear. Okay, the solution is actually pink. Okay, but at equivalence, it will change to a clear solution. Okay, a colorless solution. So I'm gonna start the titration now. Okay, just watch and see what will happen. 1 milliliter chill. Okay, I'm gonna add another milliliter chill. Okay, I add 3 milliliter so far. I have to continue. Okay, okay, it's good. Okay, keep going. Keep going. Good. See that the solution in the beaker is now clear. Okay, this indicates to us, this is indicating to us that we get to the equivalence point. So at the equivalence point, you're gonna have to read the volume of HCl you actually use, okay, or you actually drop into the COH2 solution. So I actually drop 15 milliliter, okay? How to write 15 milliliter? That's the volume I use of HCl. I use to get to equivalence, okay? Now I'm gonna put when you're done with this beaker, how to put the beaker on the side, get the other one, okay, and titrate the 20 milliliter of COH2 inside it, okay, by adding the HCl by increment of 1. Now that I know approximately the volume of HCl I use, okay, for the first titration, okay, I can go ahead and I can move faster, okay. Good. The solution turn clear, okay. Now, um, volume reading, I move from 15, okay, milliliter to 27.5 milliliter. So if I subtract 15 milliliter from 27.5 milliliter, it will give me the volume of HCl I use for the second titration. Okay, so 27.5 minus 15 is giving me 12.5 milliliter. Okay, I use 12.5 milliliter of HCl for the second titration. I'm gonna continue to the third one. Okay, okay. So I get to equivalence. The solution become also clear. Okay. So I drop I move from 12.5, from 27.5 I get to 41. You record the volume of HCl you use for the titration of the three beaker, right? And by the end You're gonna add the volume in each. For each titration, you have 3 volume of HCl, 3 different volume. You add them up, divided by 3. So you need the average of the volume, okay? And you're gonna use the average volume of HCl to actually proceed to the calculation part of the lab, okay? The calculation part of the lab will lead you to the determination of the molar solubility and the Ksp of CaOH2. Now you're done with the titration part of the lab. Make sure you clean up, okay? When the titration is over, make sure you clean up. So clean up mean here you're gonna dump those solution into the liquid waste, okay? We have in the lab, make sure you dump it. If you have a solution of HCl inside the burette, make sure you drain it out, drain the rest of HCl out. That's what I'm doing now. You drain it out, and then uh, you wash the burette with water, okay? You don't have to take it to the sink. All you have to do is to get a beaker, fill with water. You come to your lab station, okay? You pour your water inside, fill it up to 50 with water, okay? And then you drain the water out. That's how you get your burette clean, clear out, or wash out. Okay, so thank you for your attention.